Thank you very much for that introduction, and it's really an honor and a privilege to have the opportunity to speak to you today. HKV has been a major institutional support and space for building interdisciplinary conversations about the Anthropocene, and all of us who care about the Anthropocene are in debt to the great work that's being done here. And thanks, I also want to thank my hosts at the Max Planck Institute for the History of Science for supporting my trip to Berlin. Rather than repeating things I've worked out and that perhaps you've heard about or read in other places, I'm taking a risk with my talk today. I want to tell you about a digital storytelling project that, together with collaborators Jennifer Dager and Alder Kellerman, we call Feral Atlas. This is an unfinished piece of work, still in planning, although I've worked on it for a few years. You'll hear more about process than about product. Through this, however, I hope to address several important questions for scholars of the Anthropocene, including the following. First, how might natural scientists, humanists, and artists use field-based curiosities to work together across disciplinary divides to study the Anthropocene? Second, can we find ways to tell terrible stories about the environment, yet stories that energize listeners rather than making them feel overwhelmed and paralyzed? Third, might digital media help us offer stories of emergent and open-ended political ecologies at varied, incompatible scales? And this despite the most well-known use of computers to facilitate choices within closed worlds of data. I'll come to each of these questions in my talk. But to get to them, I need to establish a starting point. I'm arguing that we can do better than study the Anthropocene as a homogeneous planetary phenomenon. Instead, what if the Anthropocene is patchy and more than human? Exploring this claim guides my thinking on the Feral Atlas project and the three questions I mentioned. I understand and acknowledge that planetary scale thinking has been incredibly important. We couldn't do without planetary climate models or great acceleration J-curves. Yet, I'm arguing, to really give them their due, we need to learn more about the many scales in which our planet operates. This brings us to patchy Anthropocene. Similarly, acknowledging the role of human activities in Earth systems is essential, but to keep this point for humility rather than another round of modernist hubris requires careful attention to just how humans and non-humans together make worlds, and at every scale. As an approach, patchy Anthropocene works to bring into view those many scales and the ways they do not fit neatly together. Consider climate change, which has been the most important popular figure for the Anthropocene. Climate change is generally discussed through a space-time construction in which the planet itself is the unit of analysis. While there are new ways to visualize CO2 patches in the atmosphere, clustering, for example, around cities and industrial production, we still mainly think through planetary unity in discussing climate change. As a result, scholars and pundits have been worried about how to get us to think big, since our experiences are, in comparison, small. How might we grasp the immensity of planetary deep time and the hugeness of hyperobjects? This is useful, but not enough. The Anthropocene also requires taking geological and ecological processes down to smaller scales, and particularly the scales in which human and non-human histories intertwine. Climate change at a planetary scale alone is not good enough as a trope for the Anthropocene. Climate change has varied scales. Climate change is enacted and experienced through air, water, and landscapes, and these require attention to ecological patches. It may be useful here to both acknowledge my debt to and my difference from another scholar in the human sciences. The historian, Deepesh Chakrabarty, deserves a great deal of credit for getting conversation about the Anthropocene going among humanists. Chakrabarty takes climate science seriously rather than just talking about its rhetoric. The first thesis in his 2009 essay, The Climate of History, still rings clearly as the reason for scholarship on the Anthropocene. Anthropogenic explanations of climate change, he writes, spell the collapse of the age-old humanist distinction between natural history and human history. As with many other scholars of the Anthropocene, I follow his lead. And yet, in stressing the hugeness of planetary time and its distinction from anything historians have ever touched, Chakrabarty leaves us stuck in a dilemma. There are two different kinds of history we can engage in, he tells us. One is a humanist history of globalization. The other is a species history of planet making. These are not the same. Environmental history, he argues, is still humanist history because it does not show us planetary geology. Harking back to Chakrabarty's best-known work in post-colonial theory, we might call these two alternatives History 1 and History 2. In his earlier work, History 1 referred to Western historiography, while History 2 encompassed the time of gods and spirits, which Western historiography cannot touch. Anthropocene History 2, in both contrast and parallel, is the species-wide time of Homo sapiens, not the time of capitalist workers, peasants, and soldiers, which is History 1. In each case, the two kinds of time, History 1 and History 2, stand in tension. They do not bridge into historical translations. This makes the analysis a useful critique, but also a wall against which scholars can only bang their heads. Chakrabarty's message for historians is to open their perception to geological deep time. My task pushes both with and against this to ask how ecological dynamics, including geology, mesh with human histories. In this, deep time is not enough. Sometimes abrupt ecological shifts happen very quickly and in very particular places as they respond to human infrastructures and more than human movements and events. Considering the following situation, which I read about recently in the New York Times. Louisiana, at the southern edge of the United States as it reaches the Gulf of Mexico, has, like most low-lying coastal areas, always suffered from floods and storms. The rising oceans and unpredictable weather of the Anthropocene, however, make this situation more terrifying. In the last century, the flooding problem was exacerbated by the loss of wetlands, which protect coasts from flooding. More recently, in response, state authorities banned the net destruction of wetlands and promoted the extension of the local species of Phragmites reed. Phragmites grows in dense stands along the coast, and it protects the land behind it. However, an exotic scale insect from Asia has now moved into the region, and it's killing the reeds far faster than they can grow back. My slide shows patches of dead reeds killed by the scale insect. Without the reeds, the coast is really vulnerable. Local ecologists are between a rock and a hard place. The only solution that they can think of is to introduce the European species of Phragmites, which has been a terrible invasive species in North America, crowding out native coastal and wetland ecologies. But without any reeds at all, climate change is likely to submerge the coast completely. Climate change acts through a reed and the scale insect that's eating it. Climate change is, of course, bigger than the Louisiana coast, but on that coast, it can only be understood in relation to state policy on wetlands and the life and death of the local species of Phragmites. Climate change writ large is not enough to tell us anything about what's happening there. Instead, we need human and non-human histories woven together to observe ecological enactments involving climate change. It's not possible to separate out biology and geology here. The difference between land and sea as Earth system forms comes down here to reeds and the insects that eat them. Local to global histories, human and non-human, come together in a place. The planetary makes no sense without such enactments across water, land, and air. This is why we need attention to patches and not just the big and the deep. Climate change taken by itself is not a useful trope with which to think the Anthropocene. Instead, we need patchy Anthropocene, in which even the most powerful and most well-distributed global circulations are enacted through air, water, and landscapes, that is, patches. Thus, too, the violence of the Anthropocene, human and not human, it's always patchy. This way of approaching the Anthropocene emerged for me as a part of my work with AURA, Aarhus University Research on the Anthropocene. One of the goals of our group has been to see if natural scientists and humanists might find new ways to work together, particularly using the impetus of overlapping kinds of curiosity involving field observation. One of our field sites is the place shown in this slide, a former brown coal mine in central Jutland in Denmark, which is now filling up with weedy exotic trees and feral animals. We also have a slow seminar, slow in philosopher Isabel Stenger's sense of the term, meaning taking the time to figure out what matters. As you might imagine, we don't always find common ground across disciplinary divides. One heated discussion took place a few years ago when we read a book on Anthropocene mass extinctions. The humanists objected passionately that the book reified science to tell apocalyptic stories. The scientists were shocked that the humanists didn't accept those findings. This conversation, indeed, helped first give shape to Feral Atlas. I had thought the book we read was making an important, indeed mind-blowing point about extinction. But the more I looked around at Anthropocene discussions and far beyond Aarhus, the more I saw humanists rejecting environmental bad news. Rather than allying with the political anger of natural scientists, which shows us how we're destroying the world, my colleagues in the humanities reject it. Instead, my colleagues argue for hope, the pleasures of rambunctious gardens of weeds and invasive species, and the sweet intimacies of human interactions with non-human survivors. One version is ocean optimism, a movement that calls for telling stories of a few saved corals, rather than noting the massive deaths of coral reefs across the planet. My research on mushrooms has been recruited for the hope trajectory, and so I felt a special responsibility to address it. Blocking out bad news seems to me a terrible idea. And yet I also learned from what the humanists are saying, we need better stories. If we want to do a better job of communicating about environmental bad news, what kind of stories might we tell? What stories do not induce paralysis, but instead invigorate thinking and encourage action? It was in worrying through this problem that Feral Atlas was born. Perhaps you can already see how Feral Atlas depends on patchy Anthropocene to address the challenge of telling bad news. Instead of addressing planetary challenges as one giant fatberg, Feral Atlas asks how particular human infrastructures have created out-of-whack ecologies, that is, ecologies that bring us into the Anthropocene. Our first answer to the storytelling question is to stay with specific human histories and structures rather than diffuse humanness and encompassing planetness. We show how seemingly unremarkable structures such as roads, global shipping routes, power stations, and plantations radically transform landscapes in ways that allow certain beings to proliferate and others to suffer. Stories of such transformation show us terrors, but do not stop us in our tracks. Sometimes, indeed, they show specific infrastructural changes that could make a big difference. The infrastructures we're concerned with in our project are materialized ambitions for transforming land, water, and air to meet imperial and industrial goals. I'm tempted to call them infrastructures and industructures to distinguish them from the broader meaning of infrastructure as any social architecture, human or not human. Our subset of materialized human ambitions takes us to the last 500 years since the European invasion of the New World, but thickening with the rise of capitalism and the Great Acceleration. Feral Atlas collects stories about how human-built infrastructures cause environmental change. Our feral entities, living and non-living, transform and thrive in the materializations of empire and industry, knocking out native ecologies and in many cases causing world-ripping ruptures in modes of living in common, human and not human, forged over deep time. Feral here does not mean escaped from domestication, but rather enabled by human infrastructures and activities, but not under human control. To show you what I mean, let me turn to those pests and pathogens produced and spread in a particular instance of what we're calling an infrastructure, the plantation. Plantationocene, a term coined in a public discussion I had with Donna Haraway, Scott Gilbert, and others, refers to the regime-changing importance of the plantation in planetary ecology. The plantation is a form of ecological simplification in which plants are disciplined to become reproductive machines for the profit of long-distance investors. Plantations became models for industry. Today, many planners imagine the whole world as a real or potential plantation. Plantation is an infrastructure in Feral Atlas because it's a mode of imperial landscape transformation through which many feral entities arise to move into the world far beyond industrial agriculture. The success of the plantation as a model for industry emerged from European colonial settlement in the New World. Crops were disciplined by genetic homogenization, monocrop cultivation, life cycle manipulation, fertilization, and irrigation, and coerced human labor was imported to do the work of keeping this plant factory running. Here I've offered an image of a modern cotton plantation, but on its margins, I've tried to suggest that it's haunted by slavery on the one hand, and on the other, by the pests and pathogens it encourages, here, the boll weevil. Slavery haunts the plantation because it makes the continuing violence of this model of cultivation evident. Boll weevils haunt it because they illustrate its feral excess. Boll weevils evolved together with the domestication of cotton in Mexico, but they were never a pest until the rise of the cotton plantation in the American South. By grouping all the cotton plantations together in an exclusive space, planters also gathered cotton-eating boll weevils who used the concentrated resources of the plantation to reproduce in fantastic numbers. Boll weevils eat many plants, but only cotton stimulates their reproduction. Monocrop cotton catalyzed a population explosion for boll weevils, which now have migrated to cotton-growing areas across North and South America. As imperial and industrial ecological simplifications, plantations are nurseries for pathogens and pests. This happens in several ways. First, plantations are a gathering place for pests, just as the boll weevil has come to cotton. Second, plantations facilitate the rapid reproduction of pests and pathogens who have a warehouse of specialty food to gorge on, as well as a nursery for their children. Third, under these conditions, pests and pathogens often transform themselves, becoming more virulent and effective at finding hosts, and often attacking new hosts beyond the plantation. Let me illustrate the second and third of these mechanisms. Heterobasidium anosum is a fungal rot that infects conifer trees. In an ordinary forest, it doesn't do much harm, but in a plantation, it wreaks havoc. The root rot it causes is the biggest disease cost for plantation investors around the world. This is because Heterobasidium knows how to take advantage of the affordances of the plantation, where the closely planted trees are all the same. Heterobasidium has two kinds of livelihoods, one on the dead wood of stumps, where spores start an infection, and one on live roots. But the roots of the genetically close denizens of the plantation intertwine, forming grafts with each other, live connections from tree to tree. Heterobasidium passes easily from stumps to live trees and from one tree to another through these natural grafts. Where better to find stumps and live trees all connected underground than the plantation? No wonder that on the plantation, Heterobasidium is everywhere. All this might be amusing, a slap in the face of plantation investors, except that plantation Heterobasidium has gained talents that allow it to infect new hosts and to move beyond the plantation into the rest of the world. Anosum root rot has been found to be a set of cryptic species, that is, closely related types that are hard to differentiate from morphology alone. Until the anthropogenic spread of conifer plantations, each of the species lived in a particular region and did not travel far. But investors have planted conifer plantations around the world, spreading and mixing all the different kinds of Heterobasidion. In the process, new hybrids have formed, and they've jumped over the plantation fence, infecting new kinds of trees, from oaks to sequoias. The plantation has bred a killer of natural woodlands. This process is even more evident in the rise of new and virulent Phytophthora water molds, great killers of trees. Phytophthora learned from fungi how to get inside plants, but instead of forming the variety of beneficial to parasitic relations fungi form, they go straight for the throat, killing their hosts. Yet until quite recently, Phytophthora were specialized and scattered. It took the concentration of the industrial nursery trade to bring together all the Phytophtheras of the world, together with their soils and plants, in nursery sheds. There, they proceeded to hybridize, forming virulent new forms that attack all kinds of hosts that have never before been targeted, such as European alder. Meanwhile, cargo ships now carry soils and plants across the world in huge quantities. The inside of even one cargo ship container, with its 18,000 seedlings, is a plantation, that is, a monocrop concentration of plants and an Eden for pests and pathogens. Through cargo ships, this plantation travels around the world. A shipment of ornamental plants from Germany to my town in California brought Phytophthora ramorum in the 1990s. From my town, plants were shipped across the U.S. West, and with them, Phytophthora. The ornamental plants did not die, but the Phytophthora, which travels poorly without human assistance, jumped from the ornamentals to infect natural woodlands across the western United States. The result has been an epidemic we call sudden oak death. Woodlands are collapsing all around. These are anthropogenic woodlands, long associates with humans, but they cannot stand up to this new disease. A floating plantation, an industrial infrastructure, has stimulated an epidemic. The Phytophthora story both enlarges the concept of the plantation to include related industrial concentrations and also sets it in continent-crossing motion. There are multiple scales at stake here. The cargo container, the woodlands of California, the stream of commercial connections between California and Europe, the industrial nursery sheds that concentrate exotic plants on both sides. Feral ecologies created by plantations jump across continents, refusing containment as local or generalization as planetary. Even when Anthropocene phenomena are cross-continental, this story argues, they need to be understood in relation to the patchy occurrence of infrastructures, including the plantation form. Just because an ecological problem is big does not mean that it's homogeneous. Once a plantation-bred feral creature jumps out of the plantation, it's difficult to get rid of it. Plantation ecologies are resilient. It's hard to go back to previous ecologies. This general Anthropocene problem has the lovely, scary name of hysteresis, which reminds me of the reasons we should be hysterical, even if that word has a different root. The Plantationocene is a time of spreading ecological terrors created by modernist simplifications. I tell Plantationocene stories because I do want listeners to be afraid. But this brings me back to storytelling and feral atlas. Let me pause a moment to talk about the pleasures and dangers of digital storytelling. When I started the project, a few things were on my mind in choosing a digital format. First, the project could incorporate sound and image as well as text, and this could facilitate the meaning of atlas I had from the start, a compendium of incompatible scales. We could show how multiple scales work rather than just explaining it. Second, in a collection of cases, a digital format can make it possible to go back and forth between argument and explication over and over, making points come to life. This seemed better to me than either the chaos of autonomous contributions or the grinding discipline of editorial hyper-control. Third, in a world in which my students don't much like reading, it seemed worthwhile to try out a platform in which they'd not yet grown tired. All these made a digital format sound exciting. But I was naive. Over time, I've mainly learned that most digital experts use computers for other things, and that they take their uses so much for granted that they forget that there might be other possibilities. The most sophisticated users are those who worry about big data and algorithms for making sense of it. This is fine with me, although I'm sorry to live in a world where so much new research is merely the manipulation of existing data sets. Curiosity about the world suffers. And it's worthwhile repeating that this kind of research depends on the integrity of the data collection, which becomes the closed world in which questions are asked and answered. When the manipulation of data sets becomes naturalized as the meaning of research, it becomes harder to make room for other modes of discovery, including fieldwork. Meanwhile, there's a second, more arts-oriented set of digital experts today, those who work with interactive digital media projects. I had to learn that interaction means something very specific here, that is, the act of choice by users about what elements of the site to activate. As with big data, a set of algorithms is set up, but here to respond to users' choices. This is also a closed world, a world in which all the material is set, and freedom means choosing among internal options. Because of the parallels with the manipulation of big data, I like to think of interactive media as small data. Instead of asking what the data reveals, however, the fetishization of individual choice drives an experience-oriented program for the user. I'll admit I was surprised to hear experts in this field explain that to show a short film or to offer a text with no possibility of the user clicking onwards generates a sense of passivity and entrapment in those who expect to be always able to chart their own routes. However, there's certainly techniques here, as with big data algorithms, that come in handy for Feral Atlas. Feral Atlas is not an encyclopedia. We're not trying to compete with the many indices of invasive species already on the web. Instead, it's a limited set of stories with an argument about the infrastructure of the Anthropocene that binds the stories together. Feral Atlas is also not dedicated to interaction in the sense I've just described, although there will be interactive elements in Feral Atlas. Instead, we're trying out forms of experimental storytelling. We expect users to work their way through the project's argument about the Anthropocene on their way to case studies. We show each case of feral dynamics in its relation to imperial and industrial landscape modification projects, that is, what we're calling infrastructures. The cases, in turn, open discussion of what we call feral qualities, that is, analytic tools to help us understand the way non-human entities become feral actors. In this section of my talk, I turn to three forms of experimental storytelling that we offer, and some of the case entries we're working on to make this happen. One, juxtaposition. The clear focus of scientists becomes tangled with the openness of humanists. Digital media allows users to rub voices up against each other in varied ways, creating an array of effects. By including stories written by natural scientists to stand beside those offered by humanists and artists, we attempt to create a space for research that offers multiple entry points. In every case study, human and non-human histories intertwine. Humanists and scientists are equally full of wonder as well as sorrow. But our natural science contributors are perhaps more confident about their knowledge of non-humans and thus angrier and more specifically critical about what's happened to them. In contrast, our humanist contributors strive to build awareness of non-humans into stories of political ecology. Through Feral Atlas, we hope to stimulate a future research imagination in which young scholars might train themselves to begin projects at this intersection rather than adding one side or the other. Consider the combined precision and properly righteous anger of Michael Hadfield, a biologist at the University of Hawaii. In this and everything that follows, I'll quote, but selectively grabbing a small piece here and there to introduce but not exhaust the essays I present. Even in the 1950s, it was expected that prior to field release of alien species for biological control, here against African giant snails, laboratory studies would be conducted to determine that the predator will eat and hopefully control the target species, and that the predator is sufficiently specific in its prey selection that will not impact other non-target species. However, there is no evidence that such investigations were ever undertaken for the snail predators brought to Hawaii. The worst of these predatory snails is Euglandia rosea, a native of the southeastern US, where it's known by the common name rosy wolf snail. Hawaii is, or rather was, home to more than 750 species of land snails found nowhere else in the world. Among these is a radiation of about 100 species of tree snails in the family Acatinellidae that have large, beautiful shells, each species endemic to a small region of a single island. At the time of European colonization of Hawaii, they were present in incredibly great numbers. Now I'm skipping to later. Because the Hawaiian tree snails had become so rare, while still being nearly unknown other than as shells, research begun in the 1970s focused on non-destructive demographic field investigations by individually marking, writing letters and numbers on their shells, and measuring shells in several different locations. Hadfield and colleagues, that's my author, gathered somewhat amazing and simultaneously alarming new information about them. They found that born at around 3 to 4 millimeters in shell length, the snails grow so slowly that it takes them up to 5 years to reach maturity. Additionally, the Hawaiian tree snails produce only 4 to 6 live-born babies each year. This means that the native snails would be extremely vulnerable to the rosy wolf snail. A single predator could devour several generations of tree snails in a single trip up a tree. And it happened. Together with habitat destruction, rats and human shell collectors, also aliens in Hawaii, the predatory snails are responsible for the extinction of at least 30 of the 41 species of Acatinelline tree snails that once existed on Oahu, as well as countless species of less conspicuous tree or ground-dwelling Hawaiian snails. The story of predator introduction to control giant African snails has been repeated on island group after island group across the Pacific, from the Mariana and Micronesian islands in the west to Samoa and Tahiti in the mid-eastern Pacific, in each new place decimating wonderful radiations of endemic snails. Warnings about the lack of target species control and decimation of endemic snails in Hawaii failed to impress or determine local practitioners of biological control, so firm is their belief in its benefits. Extinct species, the symbols of declining biodiversity, can never be replaced. Now consider a humanist contribution from Kelsey Nagy, a geographer from Oxford University. Here one sees the researchers' enormous excitement to learn everything about plastic in order to supplement a study of urban dairy farming. Here's an excerpt. Plastic waste has increased rapidly in India's cities, and formal and informal waste streams are unable to capture and dispose of it all. India's street cattle are kept in cities as dairy cows and forage in the city's ubiquitous trash heaps and bins and consume food that is often entangled in plastic bags, which are the most common type of plastic urban cattle consume. These urban cattle reveal ways plastic acts as a feral agent, as both a solid waste moving uncontained through environments and a fluid waste leaching molecules that pervade bodies with toxic chemicals, exposing the cross-species chain through which we end up eating plastic as other species do too. The vast majority of urban dairy cow in India are dairy cows who have owners and are kept in homes or cow sheds at night. They're allowed to roam free in the daytime to exercise and forage for food. Urban dairy cattle are kept in cities to provide fresh milk, which Hindus value over processed milk for its perceived health and medicinal properties. Farmers in Mysore, Karnataka, can earn 10 to 20 rupees per liter of milk more than village farmers and keep a herd of 3 to 10 cattle to support their families as a sole or supplemental source of income. However, high feed prices factor into many farmers' decisions to turn their cattle free during the day to find supplemental food. Not only do people consider it normal for cattle to consume food waste, I observed during my research that cattle also seem to prefer eating it. Trash heaps and bins were scattered throughout the city and often contained kitchen scraps intermingled with plastic and other debris. Even when fresh grass was available, urban cattle were drawn to trash heaps as a place to quickly consume a number of calories and a variety of food types in a single place. Plastic pollutants travel through environments and bodies, escaping human notions of containment and control. Because these chemicals can mimic hormones, even a small exposure to phthalate at the right time can cause unintended impacts in the person exposed or to their future generations. We not only become what we eat, but also what our food eats. And at times, in an increasingly plastic world, the materials that touch, preserve, and manufacture our food too. Read side by side, Hadfield and Nagy's cases produce an effect greater than either entry alone. Human and non-human histories cannot be separated. Scientific and humanistic training, respectively, build into the historical understanding of each case. The goal of Feral Atlas is to magnify this effect across 40 diverse cases so that users might begin to see the Anthropocene through the patch ecologies that only this kind of transdisciplinary juxtaposition can bring to light. 2, comparison. Feral qualities bring cases into dialogue. Feral Atlas works toward a vocabulary with which to understand the forms of ferality we identify. We abstract from a variety of situations, looking for principles of feral action. This should allow users to read beyond the specificity of cases, looking for forms of agency. For example, we call one feral quality partners, meaning that at least 2 non-human entities work together to further feral proliferation. Partners ride Anthropocene infrastructures together. This kind of quality links unexpected patches, reminding us of the difficulty of abstracting single agents in analyzing environmental crises. Here's historian Kate Brown of the University of Maryland explaining the partnership of radioactive cesium and Chernobyl blueberries, which allows radioactivity to travel commercial circuits around the world. The berry pickers ride along on bicycles or pile out of cargo vans. Oops. They're young, mostly women and children, lean, suntanned, with hands stained a deep purple. Since the Chernobyl nuclear accident in 1986, rural communities in northern Ukraine and southern Belarus have been struggling to make ends meet. Since the late 2010s, surprisingly, towns of the Polisia region in northern Ukraine have become boom towns. What is charging the local economy? The mass harvesting of wild organic berries and mushrooms from the marshy forests. This new local economy enriches the global diet with radioactive cesium from the 1986 Chernobyl accident. The pickers know the forest and where to find its fruits ancestrally. In this territory of mineral-poor soils, plows and wheat farming never thrived. Polisians instead have subsisted on forest products, game, fish, berries, herbs, and mushrooms. What is new in the past few years is the industrial-sized scale of berry harvesting. Hundreds of buyers line the roads, and each buyer purchases a couple of tons of berries a day in high season. Ukraine's export to Europe of wild organic Polisian berries has increased more than 30 times since 2014. Ukraine has recently surpassed Canada as the larger exporter of berries to the European Union. After the blueberry season, pickers return to the forest in August for cranberries and in the rainy autumn for mushrooms. Long before Chernobyl's 4th reactor blew, scientists understood that Polisian swampland, with its dense tangle of bogs, streams, lake, and quagmire, were very good at recirculating radioactive isotopes and channeling them towards mineral-starved plants, which hungrily drank up the radioactive isotopes that mimicked minerals needed to survive. Berries and mushrooms are classic forest products because they take what they can from the poor forest ground. Polisians, also classic forest dwellers, have learned to do the same. Buyers sell the day's purchase to a wholesaler at a large warehouse. There, a radiation monitor swings a wand over the dark purple berries studded with small emerald leaves. J, J, she repeats, indicating that the berry's count of radioactive energy measures over the permissible level. Half the berries ended in the stacks above the permissible dose. The warehouse buyer purchases all the berries. They purchase the above permissible berries at lower prices. Mixing high-count berries with cleaner berries, the wholesalers reach the US and EU threshold of 1,250 becquerels per kilogram. If emergency plans call for leaving people in place after nuclear disasters, then it follows that almost everyone will share in the harvest. In the fall of 2017, US border guards stopped a truck crossing the border from Canada. Inside, they detected a large radioactive mass. Opening the container box, they found a shipment of blueberries from Ukraine. The berries were certified as within limits for the US market. The guards closed the doors and the truck passed into the United States. Radioactive Chernobyl blueberries are part of the American diet too. Chernobyl is going global. Another set of entries that gives rise to our attention to partners are our entries on American bullfrogs on the one hand, and on the other, chytridiomycosis, the fungal infection that's causing the death of frogs all over the world. The commercial trade in bullfrogs has spread the fungus, called BD for short, which rides on the skin of frogs, which in turn are transported on human commercial circuits. Bullfrogs escape captivity easily, invading the spaces of other frogs, and while they do not die from the fungus, they infect other species of frogs. The partners in our two stories then, bullfrogs and BD, offer a deadly combination. Here's a short excerpt from the BD essay by John Colby of EcoHealth Alliance and veterinary ecologist Lee Berger of James Cook University. Amphibian trade involves live amphibians packed in high densities inside shipping containers that lack adequate security to prevent escape during transport. These animals are often held in stressful, dirty conditions, increasing the likelihood of immunosuppression and disease transmission during transport. Furthermore, the substrates carrying these amphibians, such as bags of water and cardboard boxes, often become contaminated with BD from contact with infected animals and may continue to spread infectious particles if disposed outdoors or reused in subsequent amphibian shipments. To provide context of the magnitude of BD dispersed through this pathway, we randomly sampled amphibians immediately upon importation in the United States and detected BD in 58.8% of 102 food trade bullfrogs sampled on arrival from the Dominican Republic and 11.7% of 265 exotic pet trade amphibians arriving from Hong Kong. In addition, this trade activity frequently created BD-contaminated shipping materials, including 59% of the cardboard boxes carrying bullfrogs from the Dominican Republic and 5 of 8 bags of water carrying amphibians from Hong Kong. It's been estimated that the deaths caused by BD have resulted in the decline of at least 200 amphibian species. What work does the comparison between radioactive blueberries and BD comparing bullfrogs do? For me, it's both similar and different from the comparisons I offered earlier, working through the infrastructure of the plantation. There, I hope to show how a conifer root rot, boll weevil insects, and Phytophthora all emerge from the same kind of ecological simplification. Plantations make Anthropocene patches in similar ways. Here, in contrast, I'm looking at how the feral entities move around, how they attach to other beings, and how in doing so, they take advantage of human infrastructures such as commercial shipping. The focus has changed from stimulating structures to forms of agency. Here, equally, however, the goal is to catalyze thoughts about cases that are missing from feral atlas. That is, to make it possible for users to re-witness the world around us in new ways. Three, layering. Not all accounts will be alike, but translations abound. We've chosen contributors, for the most part, who've done primary research with the feral beings they describe. I've gone out of my way to include bits from the essays about the research. It's important to us to show that actually, let me go back to this, sorry. It's important to us to show that the practices through which researchers make their statements matter. Taking research practices seriously goes a long way towards countering the idea that there are two separate philosophical universes, sciences and humanities. We want to encourage forms of curiosity that do not link themselves neatly to ideological positions on the status of the Enlightenment. However, this is not enough. We've also tried to include at least a few accounts that start from entirely different premises about life on Earth. And yet, we're committed to allowing crossovers between indigenous and settler colonial forms of knowledge as each gets involved in lively landscapes. Some entries will have dual forms. For example, a personal meditation on the loss of the elms that defined one UK woman's childhood, together with a scientific account of the production of new virulence in Dutch elm disease, which killed off UK elms. Others will contain hesitations about the Enlightenment in the midst of a single entry. Here's an excerpt from outside the Academy, a painting we commissioned from the Yolngu community of Northern Australia, together with a short essay by Aboriginal artist Russell Ngadiali Ashley. Now maybe you can understand this picture. Before, goannas weren't here forever. In the olden days, people spent time hunting them. Now a stranger has come. White fellows call him cane toad. We don't know him or where he's from, but he came and killed animals, including Janda, the goanna. When Yolngu went looking for Janda and found so many dead, they started crying for him. They still feel great sorrow. We always sing and dance Janda at ceremony. Yolngu have law for Janda. We see all those Yolngu sitting around and singing about Janda. You can see the old men with spears, people singing, playing didgeridoo, clapstick. Women are dancing. They do this because Janda is their dreaming and their law and sacred identity. Yolngu are worried. We have ceremonies and stories for Janda. But the cane toad came in their secret way, and then they speared the goannas and other animals dead with their poison spear. We still have the law. We can dance for them, Janda, but they are gone. We still got law. We can't forget. We can't forget about Janda or any goanna. Now the cane toad is everywhere. How are we going to send them back to where they came from? What can we do? That's what the warriors are thinking. Look, one warrior has his arms out. He's just standing there. He doesn't know what to do. Using this painting and essay opens doors for Feral Atlas, and we have to learn to live up to it. Yet it would be a mistake to isolate it, refusing to acknowledge the collaborations, human and non-human, enlightenment and otherwise, through which cane toads made themselves known to Yolngu artists. Despite the differences in world-making practices this essay opens, we plan to link the entry through attention to infrastructures and feral qualities to translational categories formed in the intersections of all the kinds of knowledge thrown together in the atlas. Lines of incompatibility are part of the mixture, not a reason to refrain from mixing. It seems equally important in this light to acknowledge the exotic forms of Enlightenment knowledge that have come to haunt our times, and particularly those that support the most dangerous features of the Anthropocene. One entry that attempts this exoticization is anthropologist Rachel Seifer's essay on the normalization of herbicides and the herbicide-resistant weeds that make it necessary for farmers to use stronger and stronger poisons to maintain monocrop deserts. Here's an excerpt. While doing research in Argentina on the transition between cattle and soy plantations, I was stunned by the fact that plants had evolved resistance to so many herbicides. But the farmers I worked with seemed ambivalent, even cavalier, about the presence of these weeds. Farmers expected these weeds to emerge and develop resistance. This was because most of these farmers had never known farming without herbicides. From their own experiences, they'd learned that with herbicides come herbicide-resistant weeds. They had used the first commercially available herbicides, atrazine and simazine, in the 1970s. A new class of resistant plants emerged in response to their repeated application of these chemicals. So the farmers turned to ALS and ACK inhibitors in the 1980s and 1990s. Plants responded by developing resistance to these as well. In the 1990s, farmers turned to glyphosate. Now they were operating in a post-glyphosate ecosystem. It was no longer as effective as it once had been. They returned to older herbicides that were known carcinogens, such as 2,4-D and dicamba. In just a short 40 years, farmers had learned to live with herbicides and herbicide-resistant weeds. Something spectacular, the ability of a plant to live after being sprayed with lethal chemicals, had been transformed into something common and unremarkable. Let me return to where I began. What if the Anthropocene is patchy and more than human? Feral Atlas tries out this approach to offer stories of imperial and industrial infrastructures that change the world far beyond the imaginings of their builders, by letting loose feral dynamics in which long-established ways of living together are ripped apart, and many, human and non-human, suffer for the benefits of a few wild riders on the infrastructures of the Anthropocene. Feral dynamics such as those described in our atlas tell the lie of the dreams of geoengineers who promised to build us a good Anthropocene. The infrastructures they put in place will catalyze their own feral dynamics, and the bigger the scale they plan, the bigger the disasters that will follow. In this context, it's important to tell stories of devastation and ruin, as well as hope. Feral Atlas uses the patch structure of Earth's Anthropocene ecology to make those stories matter for concrete situations. Interventions are possible. Even without the digital apparatus of Feral Atlas in place, I hope my introduction to the project might stimulate further discussion on the 3 questions I identified at the beginning of my talk. First, how can humanists and natural scientists work together on overlapping curiosities? Second, how can we tell terrible stories about the environment without paralyzing audiences? And third, how can digital media aid storytelling? In ending again with these questions, I pass the baton back to you. Thank you.